In this next series of videos, let's take a look at the idea of confidence intervals for univariate data. Now, the learning objectives, what we want to do is we want to be able to construct and interpret an interval estimate for a population parameter. We want to understand the difference between point and interval estimates. We want to identify appropriate parameters to estimate based on the data and understand the relationship between the margin of error and sample size. A point estimate is the single value of a sample statistic. It's used to estimate a population parameter. This is not a new idea. We've been doing this since day 2 or 3 in the course. But this is the first time we've attached the idea of the terminology point estimate. If I were to ask you for your favorite point estimate in the whole world, up there high, a lot of people I'm sure would say, of course, X bar. X bar is a single value, hence point estimate. There's a single point along the number line someplace. Now, X bar, the sample mean, is used to estimate mu. Your next favorite point estimate would probably be something like P hat, sample proportion. That's used to estimate pi. Another one may be M, the sample median, which is, of course, used to estimate theta, the population median. All the sample statistics are point estimates, and they're used to estimate population parameters. That's really the primary purpose for their existence. Now, point estimates are, in fact, extremely useful. However, they really don't provide any feeling of I'm going to say, how good the estimate is, or how good or maybe accurate. If we did a point estimate on a proportion, let's say we're talking about upcoming presidential elections, and we say that for candidate A, the proportion based on the sample that said they're going to vote for this individual is 54%. The 0.54 would be a point estimate. Based on that, you'd say, wow, it looks like this guy or gal, whoever it is really going to be doing well. But that single value really doesn't tell us anything about how accurate it is or how reasonable it is. If we add to it the idea of an interval estimate, 54% plus or minus 2%, plus or minus 30%, see, now we got a feeling of how good or how bad this estimate actually is. Now, an interval estimate is, is bounded by two values, and those two values are calculated from the sample. And it's used to estimate the population parameter. So if I take that 54% and add to it plus or minus something, this interval that I've created is now my interval estimate. And what I'm saying is that I believe the true proportion, whatever it happens to be, is somewhere in that interval. Now, rather than using a single value, we're going to use the point estimate as the center of the interval estimate. Let's fix that so it might be readable. Interval estimate. And we're going to create those upper and lower bounds where we're going to attach to it the idea of being confident that the true parameter value is going to be in there somewhere. Now, when we compute an interval estimate, we do so in such a way that we have a specified level of confidence that the parameter value is going to actually be in that interval. See, if I said we had a sample and 54% said they're going to vote for that candidate, I said, well, 54% plus or minus 2%, that sounds pretty good. I say, well, it's 52% to 56%. There's my interval. But without attaching to it the idea of how confident I am that the true parameter value, the true proportion is actually in there, still that plus or minus 2% doesn't do any good. If I say, well, I'm only like 5% confident it's going to be in there, that's saying I'm 95% certain I'm wrong. On the other hand, if I say, well, I'm 95% confident that the true proportion is going to be 54% plus or minus 2%, that's acknowledging I'm only 5% certain that I'm wrong. So 95% probability I'm right, 5% probability I'm going to miss. The actual interval is referred to as a confidence interval. So we will be talking about the idea of constructing confidence intervals. Now, we discussed assumptions earlier when we discussed the idea of the binomial distribution. And I want to go back to the idea of assumptions again for just a moment because they're extremely important. You cannot overemphasize how important it is to justify why you're using a particular distribution. A statistical assumption is a condition that must exist, or at least reasonably so, in order to properly use a statistical procedure. We've been using a lot of procedures, a lot of techniques, and we have to justify why these are reasonable to use. It's required in order to justify, or it's required for the statistical procedure to actually be valid. See, all these procedures have assumptions. In other words, they have a certain set of criteria that have to be met in order for this procedure to be valid. So what we need to do is whenever we use a distribution, whenever we use one of these techniques, we need to justify why it's valid. And one of the reasons why we need to justify is not just to prove to someone that might be reading our report that it was valid, but it's to make sure that ourselves that we did the right thing. Okay, now this is an extremely important concept. Confidence intervals are always, always, always used to estimate population parameters. We will take sample statistics and use it as a center and add to it and subtract a certain, what we will refer to later as a margin of error to get that interval. So all those calculations is based on the sample. However, it's all about estimating the parameter value. So once we construct that confidence interval, we're saying, hey, I'm 95%, 98%, 99%, whatever, certain that the true parameter value, whatever it is somewhere in there. It's all about trying to estimate what we believe the parameter value actually is. So if I'm going to use or talk about proportions, p hat will be my point estimate plus or minus a margin of error. And I'm saying I believe pi, the true proportion, is somewhere in there. Okay, and that'll wrap it up for this brief introduction of the idea of what confidence interval is all about. In the next several segments, we take a look at actually building some confidence intervals for different parameters.